Right. Okay, we're starting a new section of work now, and that is entitled, we're going back to chemistry. Although up until now were gases, did that deal with chemistry or was that physics? Well, if you go to university and you study physics, you will do gases. Falls under a section of work known as thermodynamics. Okay? If you study chemistry, you will also do gases. Falls under both branches of science. Okay, so we've been dealing with both with both chemistry and physics on the last section of work. But acids and bases, that is back to chemistry. Right. First of all, can anyone tell me what is a base? What were you taught? Acids and? In primary school? Alkali. Okay, am I right? No. Alkali can also have a pH higher than 7. That does dissolve in water. Okay. So let's just make a note. Bases are alkalis that dissolve in so they are water-soluble alkalis. Not all alkalis are water-soluble, but if it is, we call it a base. Right, let's have a look at acids first of all. Right, who can give me some well-known laboratory acids? Hydrogen sulfate, yes. Anything else? Hydrogen sulfate, sulfuric acid is the same thing. Hydrochloric acid? What? Nitric acid. So if we just wrote some of them down, hydrochloric acid? Cl. Sulfuric acid, H2, then sulfate, SO4. Nitric acid, HNO3. What would a chemical name for nitric acid be? Hydrogen nitrate. You guys don't know your polyatomic ions. You're going to come horribly short at the end of the year. Because everything I'm going to give you in chemistry will be polyatomic ions. Don't expect nice little sodiums and chlorines. Okay? My advice to you, if you don't know what to start studying yet, go and study your polyatomic ions. Make sure you know them. Pat off, back to front. Okay? You're not going to get into grade 12 science unless you know your grade 11 science. Any other acids? What? Carbonic acid. What's the formula for carbonic acid? H2CO3. You can give me a chemical name for carbonic acid. Hydrogen carbonate. Right. Any other acids that you can think of? Citric acid. Yes, I don't know the formula of that off by heart. It's quite a big formula and complex formula. Battery acid is sulfuric acid. But hydrogen sulfurous acid, H2SO3. What's the chemical name for sulfurous acid? Hydrogen sulfite. Okay. Then organic chemistry. Have you learnt any acids there? Carbonic acids, or carboxylic acids at least? Oh yes, you people haven't yet done the organic chemistry. Right, so any acids there that you can think of? Okay, so let's just write some names next to these acids. This, we said, was hydrochloric acid. This, we said, was sulfuric acid, then nitric acid, then carbonic acid, then sulfurous acid, and lastly acetic acid. Right, any common names that you know of for these acids? Pool acid, please don't call it pool acid in tests or exams. Okay, it's hydrochloric acid. Sulfuric acid, we said, is battery acid. Nitric acid doesn't have a common name. Carbonic acid. Which of those acids would you say is the most dangerous and the most powerful, highly reactive? Sulfuric. Anything else? Acetic. Carbonic. Which one did you say is most dangerous? Acetic. Interestingly enough, acetic acid is often put on salads. It's vinegar. But carbonic acid. Any of you ever seen or worked with carbonic acid? No. Soda water. So every time you drink Coke or a fizzy drink, you're drinking carbonic acid. Okay. So they are your well-known acids. Now, what do you notice is common to all of those acids? They all begin with a one or more hydrogens, and this red pen is not working. Let's just underline them in green then if we can. No, not working. Okay, one or more hydrogens. Which hydrogen over here are we talking about? It's the last one. For some funny reason, it's always written that way. I'll draw you the structure of acetic acid. It consists of two carbons joined together. Okay? The one carbon has got 3 hydrogens attached to it, because carbon is always going to form how many bonds? 4. So that carbon over here, how many bonds has it formed? 1, 2, 3, and to the other carbon is 4 bonds. This carbon forms a double bond to an oxygen. How many bonds has this carbon now formed? 3. And then it forms another bond to another oxygen. Now, is each oxygen going to form how many bonds? What's the valency of oxygen? You guys don't know your stuff, eh? 2. How many bonds has that oxygen formed? 2. It's happy. How many bonds has that oxygen formed? Only 1. It bonds to a hydrogen. How many bonds has this oxygen now formed? 2. How many bonds do hydrogens want to form? 1. Is that hydrogen happy? That hydrogen happy? That one? That one. That carbon happy? 4 bonds. That carbon happy? 4 bonds. 1, 2, 3, 4. That oxygen happy? 2 bonds. 1, 2. That oxygen? 1, 2. Okay. So that is the structure of carbonic acid or acetic acid. Not carbonic, acetic acid. And the hydrogen, which is the important hydrogen, is that one there. So it is written CH3COOH. Okay? CH3CO, that's that oxygen, OH. And this is the hydrogen here. That is the important hydrogen. Because why are hydrogens important to acids? No. When an acid reacts, or let's put it this way, up until now, what has been exchanged when chemicals have reacted with each other? Electrons. When acids react, they transfer H pluses, not electrons. Okay? So that's why the H is so important. So let's just make a note. You may want to take that down. Okay? I'll just rewrite this. CH3COOH. How much time do we have before assembly? Still 15 minutes. Yes, but unfortunately we've sunk to the level of the Americans. Sulfur or sulfurous, sulfur, sulfuric, sulfurous should be pH. That is the correct English spelling, but it's just been universally accepted that we spell it with an F. I will not mark it wrong. I can't guarantee that. You may have an examiner who thinks he's American or she's American. Right. Can I take this off to give myself some more space? Okay. This off. All acids contain one or more H's. Okay. So which acid here contains one hydrogen? Hydrochloric. 2 hydrogens? Sulfuric, carbonic, sulfurous. Which contains 3? None, but you may want to add this one to the end. H3PO4, which is phosphoric. Sorry? No, not that I'm aware of. 1 hydrogen, we say it is monoprotic. Two H's, it is diprotic, and 3 and the diprotics and the triprotics are said to be polyprotic acids. Right, should there be an apostrophe there between the H and the S? Yes, no. Which? Does the S belong to the H? It's the H's, whatever. No. Is there a letter missing? No. So why do you want to put an apostrophe there? Right? Precisely, and it's not going to change. Okay. Now, why are we so fascinated about these number of hydrogens? Okay. Let's hope this pen lasts. Okay, why are these H's important? Well, as you said, normal chemical reactions involve the sharing or the transfer of electrons. Think of ionic reactions, think of covalent reactions, okay? But acid reactions involve the transfer of an H+. And I've written in brackets that an H+ is a proton. Is that true? Why? Doesn't have any neutrons. How many electrons does H got? 1. How many protons? How many neutrons? None. So you take away the electron, what's left? Just the proton. Okay, so an H+ is actually just a proton. And why do you therefore think that this is, we talk about protic, polyprotic, monoprotic, diprotic, because it's one proton. Okay, so you see the link between proton and protic. Right, let's have a look at a typical H Cl and water. Does that make which one of the acid? Is HCl the acid or is water the acid? Well, they've both got H. You'll find that water under certain circumstances can be an acid. But in this case, which one is the stronger acid? Obviously, no pool acid is a lot stronger than water. So this one will play the role of acid. And it will donate an H+. So an H+ will be transferred to water. And what will water become? H, what? 3O plus, because you transferred an H+. And what is left behind there? Cl minus. What was the total charge on this side? What is the charge of that thing? And the charge of that thing? What's the total charge? Neutral. What's the charge of this thing? +1. -1, total charge? Neutral. Okay. So they won't be bonded because don't forget there's water present. So depending on how much acid you add, if you add a teaspoon of acid to a beaker of water this size, that acid will break up and it will cause some of the waters to become H3O positives, and obviously the acid bits that remain will become the Cl negatives. But there will be plenty of waters that haven't been given an extra H+, and they will pack around these things with the negative oxygen part of the water around them, and the waters will pack around here with the positive H+ pointing towards them. Remember those sketches we had? That's what will happen there. Okay. What will happen if I had to take H, let's do one last one, 2SO4 plus ammonia, NH3. Which one's going to donate the H? H2SO4 will donate the H+. H+. No, just one. And it gives you H. Let's do the ammonia first. What will the ammonia become? NH4 plus and HSO4 minus. What is this NH4 plus called? Ammonium. What is the NH3 called? Ammonia. Yes. Why doesn't it? It will first give one away. Okay, and then if there's still ammonias left in the container that haven't yet received an H+, then it will start giving its second one away. So it's a two-stage process. It all depends on how much of whatever. It's just one of those things about chemistry. You've just got to learn that sometimes that's how it goes and sometimes it goes the other way. Chemistry can be a bit temperamental. Right, all understanding? I expect you to know this by Monday. You've been given a lot of information on this board. One, you need to know the names of your acids and the formulae of your acids. Okay, I'll be there in a moment, right? You need to know polyprotic, monoprotic, diprotic, etc. You need to know how these reactions work. I'm going to be checking you on that on Monday. Thank you.